Right, we now proceed on to the second part of geometric reasoning, scale factor. I introduced the term scale factor a little bit earlier in geometric reasoning 1. Now, we need to see how we could actually calculate the scale factor. Let's take a model of Sydney Harbour Bridge and the actual Sydney Harbour Bridge. We know that the length of Sydney Harbour Bridge is 1.2 kilometers, whereas the length of the model is 1.5 meters. How do we actually calculate it? Now, calculating the scale factor, we use ratio. We started off by writing actual length of the Sydney Harbour Bridge to the ratio of the length of the model. So 1.2 kilometers to 1.5 meters. Convert the kilometers into meters. So we have 1,200 meters to 1.5 meters. We can drop the meters because we are looking at a factor, which is a number. We don't need a unit. And then we actually make one side of it 1. So it could be divided by 1.5 or divided by 1,200. In this case, I've chosen 1.5. And therefore, the actual length of the Sydney Harbour Bridge to the length of the model is 800 to 1. So we can actually say that the scale factor of the actual Sydney Harbour Bridge to the model is 800. Or the length of the model is 1/800 of the actual length. Be very careful how you use it. Okay, so make sure that you know whether the scale factor is 800 or 1/800. Now, where do you actually use scale factor? You would look at scale factor in maps where you can actually calculate distance based on the scale factor given in the map. Scale factor is actually the ratio of any two corresponding lengths in two similar geometric figures. The ratio of the length of the scale drawing to the corresponding length of the actual object is a scale factor as well. So it is a number used as a multiplier in scaling, and a scale factor is used to scale shapes in 1, 2, or 3 dimensions. So I've shown you how to actually calculate scale factor. In the next video, we'll be looking at similar triangles.